Hello, everyone. I just wanted to go over some of the review with you just in case you're prepping for your test on Tuesday. So I'm going to take a look at test review number 2. If you notice, I did put the answer sheets in there, so let's just take a look at a couple together. Whoop. Taking a minute. All right, let's zoom this out a bit. So I just I'll go over some of these with you, but I figured we could talk about a few of them. So the first one was just using your vocabulary words. So remember, when you're talking about interior and exterior, you're talking about the parallel lines. Now I know these are not parallel, but they're the two lines that don't intersect in the picture. Anything between these is interior. So 3, 4, 5, and 6 are interior. 1, 2, 7, and 8 are exterior. So when we look at 3 and 6, they're in between opposite sides of the transversal, so those are alternate interior. 1 and 5, they're both in the top left, corresponding. Alternate exterior for 2 and 7. All right, they're both outside the parallel lines and on opposite sides of the transversal, so alternate exterior. 4 and 6, both interior on the same side of the transversal, so same side interior. 6 and 7, vertical. All right, they are across from each other in the same intersection. And then 7 and 8 are not alternate exterior. Okay, they're a linear pair or supplementary. They add up to 180. All right, a couple other terms that came up. 2 lines that have the same slope but a different y-intercept are parallel. 2 lines that have negative reciprocal slopes where you flip it and change the sign. For example, if we have 1/3 and then we have -3/1 or just -3, those are perpendicular. 2 lines that have the same slope and same y-intercept are the same line. They're coinciding. Not a term that you're going to have to pull out, but you might have to recognize that they're coinciding lines or the same line. All right, number 5. These are alternate interior. Look at this is acute and this is acute. So that means that they are equal to each other. 3x minus 21 equals 2x plus 19. If you're not sure how to go about solving, it's always a good idea to circle your x's and draw a line down from your equal sign. So now I say, okay, well, I got to move the 2x over. I'm going to subtract it. I'm left with x minus 21. Add 21 and you get 40. It did say to find the measure of angle FOD. Follow that path. F to O to D. Well, I'm going to have to substitute in 3 times my 40 minus 21 is 99. So if that's 99, so is that because they're vertical. All right, I'm actually going to switch over to a different document to show you this one. We'll go through it together. All right, so first of all, over here, these were congruent, so we set them equal. But on this one, they are a linear pair. They are not equal. One's acute, one's obtuse, so we're going to add them up and set them equal to 180. All right, again, if you have a hard time solving equations, not a big deal. Draw your line down, circle your x's. 2x and 3x is 5x. 1 minus 21 would be negative 20. Add 20 to both sides, so we have 5x equals 200. And then divide by 5 to get x's 40. Now it does say to find all x and label all the angles. Well, we found x. We got a whole lot of angles to label. First of all, why don't we figure out what these angles are? 3 times 40 minus 21 and 2 times 40 plus 1. So we have 81 for this angle, and we have 99 for this angle. All right, we've got everything we need, and let's just start labeling. Since this one's 81, so is this one because they're vertical. Since that one's 81, so is this one because it's either, you could say it's corresponding to this one or it's alternate interior angle with that one. And then this one's 81 also because it's vertical with that top angle. All right. So now let's go to this guy. This one's 99. So this one's 99. All right. Over here we got this 33. So this is 33 because they're vertical. And this one's 33 because these two are alternate interior. It's a different transversal. To find the obtuse angle, 180 minus 33. We're going to see a lot of these pop up this year. So 147 for the big angles here because they're vertical. All right. Oh, also up here, that's also 33. Now you've got a couple things. First of all, if you notice, the three of these angles together, 81 plus 33 plus x, would add up to 180. So you could just add the 81 and 33 and subtract it from 180. So this is 66 degrees and this is 66 degrees. And if you added all of those up, you'd end up with 180. Or excuse me, 360. All right. On to the next page. Hopefully it opens. We'll see. So review 2, page 2. It should open for you. If not, just send me an email. It was fine earlier, so it should be fine. All right, I'm not going to bother with that right now. Let's just take a look. So, given these points, find the following. All right, you need your formulas, guys. So, distance is, remember, x minus x squared plus y minus y squared. If it helps, put the x and y here. So we're going to have 6 minus 4 squared plus negative 7 minus negative 9 squared. You could put that right into the calculator if you want and go. 6 minus 4 is 2 squared. Negative 7 plus 9 ends up also being 2 squared. So we have 4 plus 4, which is 8. Take the square root, and we'll round to the nearest tenth. You've got a calculator. Second, x squared, 8. 2.82, so it'll just be 2.8. Midpoint, you're finding the middle, halfway between those. It's like finding the average of 2 quizzes or 2 tests. You add them and divide by 2. So I'm going to line them up vertically. 6 and 4 is 10. Negative 7 and negative 9 is negative 16. Don't forget to cut them in half. So your midpoint would be 5, negative 8. And your slope, y minus y over x minus x. It's technically y2 minus y1 over x2 minus x1. But that's just to make sure that you're being consistent. So do your y's. You can either do negative 7 minus negative 9 or the other way around. I'm just going to do negative 7 minus negative 9. Since I started with negative 7, I got to start with 6 minus 4 on the bottom. So negative 7 plus 9 is 2. 6 minus 4 is 2. 2 divided by 2 is 1. There's your slope. All right. Equation of the line. Well, we've got our slope and we have the point. You can use either A or B. It doesn't matter. Why don't we go with 6, negative 7? You could even use the midpoint if you want. So since we have the point and we have our slope, which we just found to be 1, you can do y minus the y value in your point. So y minus negative 7 becomes y plus 7 equals our slope times x minus the x value in our point, 6. If you graphed those, you could have found your equation the other way. So 6, -7. You're going to go to the right 6, down 7. And 4, -9. Wow, that's a tiny little line. Now it's kind of tough. You can see the midpoints right here. Look at, it's 5, -8, just like we found. All right, you can see we're going up 1 over 1 for our slope. Well, if you do that and you want to find your y-intercept, you'd have to go down. So now we're at 11, or excuse me, we're at 11, -12, -13 is where it would cross. So that equation would be y equals 1x minus 13. You could get that same thing from here if you solved for y. So y plus 7 equals, distribute that 1 through, 1x minus 6, subtract 7 from both sides, and look what we have. Y equals 1x or just x minus 13. Either of these equations would work. This is your equation in point-slope form. This is your equation in slope-intercept form. All right, and then for your perpendicular bisector, you need your midpoint, which we found to be 5, -8, either here on the graph or up above where we added the 2 points and divided by 2. And your slope, well, if our slope was positive 1 over 1, perpendicular to that would have to be negative 1 over 1. So if we want the equation of that line, you can look at it on the graph. We'd be going down 1 over 1. Or you could go up 1 and backwards 1. And this line that you're creating is cutting our segment in half, and it's perpendicular to it. It forms a right angle right here. And if you look at that equation, it's hitting the y-axis at -3. So the equation for that from the graph, if it was saying in, slope-intercept form, would be y equals -1x minus 3. Or again, you could use your point-slope formula, y minus the y value in the point, so y plus 8 equals my new slope, -1, times x minus the x value in my point. And again, you might say those aren't the same. Well, if you solve for y, they would be. It'd end up being a plus 5 minus 8 on both sides. Y equals -1x minus 3. All right, so there's all sorts of different ways to go about these. You pick the one that works best for you and go with it. Okay, the equation of a line that's parallel to this. Well, parallel means they have the same slope. So divide everything by 4. You got to get y by itself. And we get 5/4 x minus 2. So there's your slope. And it goes through this point. It says leave it in slope-intercept form. Well, I don't have the slope-intercept. I have point-slope. So we'll start with point-slope. So it's y minus the y value in your point equals our slope. It's parallel, so it's the same. If it was perpendicular, we'd switch it and change the sign. Times x minus 8. The thing is, though, right now we're in point-slope form. We want it to be in slope-intercept. That just means solve for y. Just like if you were going to graph it. Throw it in your calculator. So I'm going to leave the y minus 5. I'm going to distribute 5/4 times x is just 5/4 x. 5/4 times -8, you can type it right into your calculator just like that. 5/4, remember alpha y equals to get your fraction. 5/4 times -8, -10. And then we just have to add 5 to both sides to get y by itself. 5/4 x minus 5. So your slope is 5/4. Your y-intercept's -5. All right, a little bit more in the back. Write an equation of a line perpendicular to this. Well, this one's already solved for y, so perpendicular to negative 1/5 would be positive 5 over 1, or just 5. With the same y-intercept as this one. Y-intercept is usually here, but y is not by itself yet. So we got to divide by 5 to get y alone. So 9/5 x minus 16 divided by 5, we'll just leave it. All right, so write in the equation, here's your slope. Because it's perpendicular, we're using the same y-intercept, as ugly as it is. So your equation would be y equals 5x minus 16/5. All right, parallel to the y-axis that passes through the point 5, negative 3. Well, let's plot 5, negative 3 first. Parallel to the y-axis. Well, this is your x. This is your y. So parallel to the y means it's never going to cross the y. It's just going to run straight up and down. That means it's only hitting the x-axis. There's no y in the equation. Where's it hitting the x-axis? At x equals 5. That's your equation. X equals 5. And if you notice in your point, that's the x value. Again, if you have a vertical line and it's never crossing the y-axis, there is no y in your equation. The same is true if it never crosses the x. So parallel to the x-axis, that's 4 units above it. All right, well, here's 4 units above. If it's parallel to the x, it's never going to cross the x. It only crosses the y at 4. So your equation is y equals 4. All right, so just with those, if it's vertical or horizontal and doesn't cross one of those, it just means it's not in the equation. So if I wanted to graph y equals negative 5, if you forget what it is, because I don't want to see this. Here's your y-axis, here's your x. I don't want to see just a point there. That is the 0.05. It is not the equation y equals negative 5. But if we type it into y equals, anytime we have an equation, you can always use your graphing calculator. You can see what it looks like. Oh, okay, so there's my line. Label it. All right, well, if y equals negative 5 goes straight across, x equals 7 is going to go straight through the x-axis at positive 7. That one you can't put in the calculator. All right, and with this one, if you want, you could say, all right, the point that falls on the line, because we're in point slope form, would be positive 6, negative 2. And here's your slope. So you could start at 6, negative 2. And then you have to use your slope. So going down 2 over 3. Can't go any further. So if we go up 2, backwards 3, up 2, backwards 3, you could plot it that way. That's not something we're used to, though. So if it's easier, just solve for y. Distribute. So we'll leave the y plus 2. Negative 2/3 times x is negative 2/3 x. And then we'll do negative 2/3 times negative 6 right in your calculator. So we have alpha y equals negative 2 over 3. If you put the negative out front, that's okay too. Times negative 6. We get positive 4. All right, so now let's just get y by itself, and we're ready to graph. Y equals negative 2/3 x plus 2. There's your y-intercept of 2, which we already found when we graphed it using our point. And we're still going down 2 over the 3. Over 3, the slope hasn't changed. It's the same line, regardless of what method you use to graph it. And then just grab your ruler, draw your line. Don't forget to put your arrows in your equation. And you're set with that. So y equals, either equation's fine. All right, so that's it. Your test is going to be Tuesday. Make sure that you study, know your formulas. Might help to make some flashcards. If you have questions, let me know. Have a great day.